As Tricia just announced, my name is Sergio Pineda, and I'm with Docker. Tricia and I are peers here at Docker. And with us, we have Stephen Follis. And the way we're going to conduct today's webinar is really about helping to set the stage for a Docker Enterprise Edition and really the value it delivers to customers to address very specific requirements as they look to modernize their application infrastructure on Azure. And then I'm going to hand it over to Stephen, and then he will double-click on Docker Enterprise Edition and give you a brief demo on Enterprise Edition running on Azure. So with that, let's go and just get started. I thought I would lead off with this slide, which is really does a very nice job of encapsulating our momentum. And when I say our, I mean Docker. If you think about these slide numbers, it's way more than just Docker, right? It's really more now becoming an industry momentum. When you have hundreds of customers, you have billions of downloads, you have jobs now that are being posted seeking very specific requirements around containerizing applications, specifically with Docker Enterprise Edition. You've got a growing number of customers that are Dockerizing apps, again, with our platform, across all different industries and across all different customer segments, whether that's small, mid-market, and enterprise. And then you've got 200 plus user groups. So I think, at the end of the day, the message here is we've got not just Docker momentum, but we have a lot of industry momentum behind what's happening at the application infrastructure level of many organizations, especially in the enterprise organization. And that's really where we're going to focus today's discussion. So this slide really is intended to help you walk away with the following. I talked a little bit about the data and the industry momentum, and now really the Gartner quote really sort of validates that momentum in that, by 2020, which is really only a couple of years out, half of organizations will be running containers in production. That's production, not test environment, not proof of concept. They will have already been past that stage. And so again, you can see sort of a bit of the hockey stick effect that we're seeing with containers and the adoption of containers. And again, you're seeing the hockey stick of the jobs from Indeed.com. So you can very much see the correlation. As more and more organizations adopt containers, there's a need to hire people that have that specialty, and therefore Gartner can make that assessment that says half of all organizations will be running containers in production. And when you look at global organizations, many global organizations are by default enterprise organizations, and so that really is where we are focused on in driving and helping those organizations address their needs. So what are we seeing, and why is it happening? For those of you that are in the IT space or developers working in mid-market or enterprise organizations, you know all too well that the minute you write and publish an application, there's always going to be an effort to manage, maintain, and support it. What's happening now is there have been a proliferation of so many different types of applications that a lot of the time now is being spent managing applications, supporting them, updating them, and not necessarily having the time to innovate and develop new applications that perhaps position or propel the organization forward. Well, why is that? The competitive dynamics are changing rapidly. The customer needs are changing ever so rapidly. And so what you're seeing is server utilization perhaps not where it needs to be. And why is that? Because a lot of functional groups might be doing shadow IT, and so they're spinning up their own IT silos to respond to a customer need or competitive situation, or to address a very specific operational efficiency requirement. And so what is that driving? That's driving not just existing application maintenance, development, support, but spawning a whole new set of applications that might be cloud native and might be running in silo. And so therefore, IT has really sort of lost its handle on its ability to be able to control and manage the entire IT infrastructure. And so what's the cost associated when you have that? Essentially, a lot of organizations are unable to accelerate their transformation to a digital world. And that might entail not moving as quickly as they would like to cloud, not consolidating servers, be it on-premise or virtual machines in the cloud, or a little bit of both in a hybrid environment. At the same time, organizations are much slower to react and perhaps can't ship software applications as quickly as they would like. And why is that? Because there's only so much time, there's only so many people, there's only so much budget, and a lot of that has to be focused on looking back as opposed to thinking forward and moving forward. And so, it's not surprising to hear CIOs say that they're behind in their digital transformation. It really isn't. So in light of sort of the momentum we're seeing at Docker, in light of what Gartner is saying, and looking at sort of this key business challenge that organizations across the board are experiencing, how are we positioned to best address those needs? As organizations look to modernize their environment, they've come back to us and they've asked us for a couple of key requirements in our platform. And that is, first and foremost, give us choice. If we're going to go down the path of containerizing applications, we want to be able to run those applications, those containerized applications, on-premise, in a cloud, or across both environments. And so Docker Enterprise Edition really enables that. And it means that if your organization isn't yet perhaps made a decision on which cloud platform you want to run your applications on, you can run them on-premise. We work very closely with Microsoft, and we understand that many of Microsoft customers are just now starting their journey to the cloud. And so many customers are not about to necessarily depart with those applications that might be running on Windows Server 2003 or Windows Server 2008. They still want to run those applications. And because they have a business requirement to do so. So Docker Enterprise Edition allows them to containerize those legacy apps and run in an on-prem environment, while at the same time provide that bridge to allow them to transition and run on Microsoft Azure when the customer is ready. And so really, what are we doing here? We're helping you as our customers or future customers mitigate the risk so that you don't feel like you're locked in. Because containers are highly portable, again, you can run them across multiple environments. So second requirement, and this shouldn't come as a big surprise, is security. Security is top of mind for so many organizations today in light of what's happening around the world, where data breach is front and center now in all different industries, across all different environments. And so really what Docker has done with Enterprise Edition is to develop a model, a framework around the platform that provides sort of this end-to-end approach for governance, management of that environment, role-based control, and then this constant check to make sure that containers aren't breached. As you know, because containers run in isolation, they are by default more secure. But what we're doing, not resting on that, we're taking it to the next level. And we have a three-part webinar series, and the second part of our webinar series is going to focus just on security. So we'll be able to do a deep dive on that. But imagine the scenario of those of you that are running, are running Windows Server, and you've got the Active Directory, and you've got role-based management of policies and profiles. Same thing on Azure. So essentially, we're taking that model and we're designing a security framework so there's consistency there. So those of you that are used to assigning access to server data center resources based on role, you can now do that with us as well with Docker Enterprise Edition. And then there's the agility piece. And the agility piece, if you think about it, really ties very closely to choice and security. Why is that? Because the minute you Dockerize an application, you can run it anywhere. That means that you can spin it up and deploy it more quickly versus having to spin up an entire VM, let's say with a cloud provider. And also, of course, you can run multiple containers within a virtual machine. And so what that does is, again, that allows you to deploy multiple containers across a virtual one virtual machine, so thereby making it more cost effective. And because there's one approach to containerizing applications with Docker EE, the time to market is accelerated. And so if you can accelerate time to market, deploy a consistent approach for how you want to take legacy applications and run them across multiple environments, whether that's an existing or an emerging environment like cloud or in a multi-cloud environment, and at the same time protect them, you're getting the best of everything. You're getting choice, you're getting a high level of security, and you're getting agility, which, guess what? Agility drives cost efficiency drives saving, and all of a sudden you're starting to see the pendulum swing away from maintenance and starting to swing more in favor of innovation, which at the end is a win for everybody. The role of containers, this is an interesting chart that I wanted to share. It's an IDC study published last year. And if you look at this, the key message here is where organizations in their life cycle with container technologies. And you can see here it's sort of that very classic bell curve where we have a group that are starting out, and we've got sort of this sweet spot of roughly 50% that are either planning or in active production, and then there's those that are probably not quite yet ready. But the point here is that organizations, no question, see that they have to be looking at an alternative approach for managing and doing a much better job of getting their data centers to run more efficiently. And so that means you have to look entirely up the stack, not just at the infrastructure level, but you got to look at the application level as well and say, how can we run applications better? How can we run them more efficiently? How can we save money in the process? And so containers with Docker EE really provide that opportunity. So now you've got partners like Microsoft with Microsoft Azure that are helping you transition from your Windows Server environment, if that's the primary environment you run your applications in, providing that bridge. And now what we're doing with Microsoft is saying, all right, now that Microsoft has provided a bridge to the infrastructure, let's continue to extend that bridge up the stack into the application layer. And we're doing that with Enterprise Edition and containers. So what are the use cases? Where are customers using Docker EE and how are they using it? And this is just a sample of where customers are using Docker EE with a mix of Microsoft Azure. And you can see here that these are not discrete. If you look at one versus the other, if you look at modernizing traditional applications, in the case of MetLife or Northern Trust, every time they Dockerize a legacy application, because they can run it across multiple environments, by default, they are accelerating their app development and delivery. So that's translating into greater efficiency. Or if you look at Lockheed or Liberty Mutual, who has not yet made a firm commitment necessarily to one cloud provider over another, but at the same time, they realize that they have to go down this digital transformation journey. Well, Docker Enterprise Edition really enables that. And it enables it in such a way that works best for Lockheed or Liberty or McKesson. They decide when they want to move their containerized application to which cloud provider and when. All throughout that process, achieving gains as they go along their sort of cloud journey or their modernization journey. The same thing applies for the supply chain or reducing the data center infrastructure expenses. What are you doing when you Dockerize an application? You're reducing the VM footprint, so by default, you're reducing server. You can improve server consolidation, and so therefore you're reducing data center costs. And at the same time, you're securing your environment. So you can see here, the way I sort of tie all six together is they're not discrete. They all have they all benefit each other in one way or another. If you double click on one of the use cases, we're choosing to highlight MetLife. And so really what you're seeing here is this is what MetLife has measured. They're saying that they are achieving a 66% cost savings by accelerating app delivery. But remember, their journey was modernizing traditional apps. So what they found is not only can we run Docker EE on Microsoft Azure, are we modernizing legacy apps and making those legacy apps available to their employees or their customers that need to be able to access those applications. But at the same time, they're accelerating that time to market and achieving efficiency and cost savings. And you can see here the results that they have quantified and communicated back. Significant TCO reduction, significant VM consolidation, dramatic increase in CPU utilization, and much faster time to market. You can see here that, and they're doing it in a very secure environment. So again, hearkening back to what the value is that Docker Enterprise Edition delivers to customers, it's really about choice, it's about security, and it's about agility, which is what we see MetLife achieving by running Docker EE with Azure. So I want to close by taking a step back and sort of getting you to think about containers by themselves do offer value, no question. But at the same time, it's important to take a step back and ask yourself, all right, if we're going to go down the path where we need to modernize our environment, you absolutely need a strategy for how you're going to get there. And if you're going to go down the path of containerizing your applications, you want to be thinking about what platform and what sets of services do I want to be running as part of my containerization strategy so that I can achieve the cost savings. I can run a more secure environment. I can be more agile. I can have the choice to run across multiple environments. And so at the end of the day, really, what it comes down to is the platform you choose is how you want to be thinking about how you want to embark on your journey. And with Docker Enterprise Edition and Microsoft Azure, we can really help you get there. So to double click now, what I'm going to do is I'm going to go ahead and just stop, and I'm going to transfer the ownership to Stephen Follis. So let me just stop sharing for a second and make Stephen the presenter. And Stephen, let me know when you can, if you've got the presenter rights.
I believe so. Is that coming through, everybody?
Yep, I can.
That was a yes, Sergio?
Yes, Stephen, I can definitely see the presentation, so go for it.
Great, thank you, sir. Hi, everybody. My name is Stephen Follis. I work closely with Sergio here at Docker. My role is a solutions engineer. So I work with customers of enterprises of all shapes and sizes around their container strategy, and specifically around customers that are interested with containers and the Windows ecosystem. So those customers that are, .NET shops, or those that utilize SQL Server, more of those type of companies. And today what I want to walk through is make this a little more real. I think Sergio just walked through some excellent tips and pointers around some of the business value, the momentum, where we're seeing Enterprise Edition adopted in the enterprise. I want to kind of delve into some of the more technical details here and talk a little bit about what containers are and how Enterprise Edition delivers value on top of the Microsoft Azure platform. So to start with, I wanted to start very kind of high level. What is a container? We're assuming some familiarity for most of you on the call, but I'm sure there's a couple of you out there that you might have heard of a container. You hear the verbiage quite a bit, but it's still a little bit fuzzy over what exactly all of these container things are out there. So to start with a container, it's a way that we package software, first and foremost. It's a way for us to take application code and all of its dependencies, everything it needs to run, and then we wrap it in something that we call a container. This container wrapper is terrific for a variety of reasons. It gives us great isolation between different application workloads, so that app A can't talk to app B unless we need it to, and we explicitly allow it. And it gives tremendous benefits from a density perspective and an efficiency perspective because we share the same kernel that's running on that host operating system. This is different than a virtual machine where we actually have a full guest OS on every single virtual machine and the overhead that entails. We began in the Linux world. This was technology that had been present in the Linux kernel for many, many years. However, it was very difficult to use this isolation technology. What Docker was able to do is it took these components and they tied them together into a very easy to use user experience, a nice command line interface, a nice RESTful API, some nice developer tooling to make it very easy to use by companies of all sizes, especially those that didn't have a team of comp sci PhDs on staff to make sense of how these things work. Several years ago, we entered into a very fruitful relationship with Microsoft to bring a lot of the same technology, capabilities, and dev efficiency from the Linux world over into the Windows world. And so starting with Windows Server 2016, we've had support for Docker containers baked directly into the Windows operating system. So if you're developing with Windows 10 or deploying on Server 2016, the same great capabilities that containers offers are available to you and your workloads. As far as how these are put together, I've got kind of a high-level diagram to kind of help demonstrate the differences between something like a virtual machine and a container. So in a virtual machine world, the way we've been virtualizing application workloads for the last, 5, 10 plus years, we have a layer of infrastructure, typically either bare metal or a cloud provider with a hypervisor on top that's running one or more virtual machines. Inside of each virtual machine, we have an application, one or more applications, all of the bins and the libraries that it needs to run, and an entire guest operating system. In the world of Windows, this is likely a very large operating system, tens of gigabytes of OS space that is needed to run, large amounts of compute resources and memory that need to maintain that application. And these virtual machines typically stay up for months or years at a time. We patch them, we take good care of them over the long term. They produce quite a bit of management overhead for us. Containers are a bit different. So in containers, instead of that hypervisor layer, we have something called the Docker engine. The Docker engine is what talks between the host machine's kernel and allows us to then create one or more containers on top. These containers are different that we don't have that full guest operating system, resulting in a much more lean, more efficient application deployment method. We can spin these containers up and tear them down very, very quickly, talking in mere seconds rather than minutes or more for large VHD, VM type deployments. These containers, because of that speed and the notion of immutability that's current in the container ecosystem, allows us to be able to stand up these containers. When we need to patch them, we can simply just delete container version 1 and then spin up version v2, allowing us to move very quickly and not have to worry about rolling back or modifying that VM operating system that's present. In addition to containers that we've had in the Linux world and the Windows Server world, Microsoft has done some interesting innovation in this space as well. And I want to make sure we call out something called Hyper-V containers. I mentioned earlier that for standard Docker containers or Windows Server containers, we're sharing the kernel of the host operating system. However, for more secure deployments for customers that have regulatory needs, around sharing of a kernel, we can actually use something called a Hyper-V container, which spins up a very lightweight virtual machine with its own kernel inside. Now, these Hyper-V containers are not nearly as efficient or dense as their standard brethren. However, they give an opportunity for more secure running of application workloads. And this historically has been possible for Windows containers, and very soon there will be support for Linux containers as well, running on top of Windows Server 2016 via Hyper-V containers. That's a very quick look at containers and how these relate to traditional virtual machines, which are typically more familiar. As far as another quick kind of overview of how we create these containers, this process is not something that is invasive. We've tried very diligently to not move the cheese for your developers and your operations team, so to speak. So we want your team members to be able to build and deploy applications just like they always have, without having to have months and months of ramp time and lead time before they can be effective. So when it comes to creating these containers, we start with your existing application code. You don't have to tear that application down. You don't have to start from scratch, throw it away, and recode in some new language. We start with what you've got today. Then we add something called a Docker file. A Docker file is simply a recipe card. It's a set of instructions of how an application needs to run inside of a container. This is where we add all the dependencies. We may add entries to adjust the Windows registry. We may add environment variables. We may run certain startup scripts through PowerShell to configure the file system in a particular way that the application requires. Anything that we need to do to set up a container, we place in this Docker file. And I can show you an example here in a moment. It's a declarative format that can be checked into source control, can be versioned, and can evolve as your application evolves. Once it comes time to create that container, we do something called a Docker build. A build is a compilation step that takes your application code and your Docker file and smashes them together, generating a Docker image. This Docker image is that highly portable asset that we can then move between different machines, that we can check into a registry, that we can be able to instantiate multiple containers out of. So if I wanted to create multiple containers, I can utilize something called a Docker run and create multiple containers out of this. That would work well on my own personal development machine, but if Sergio or somebody else in my organization was wanting to utilize that exact same Docker image, they'd need a centralized place to get that from. So the last piece of kind of verbiage I want to talk about is a Docker push, which is how we take a Docker image and we push or upload into something called a registry. A registry functions very similarly to source control. You know, in a source control system, you are saving, it's a central spot to save all of your source code for your applications, whereas a registry is a centralized spot to store all of your Docker images across an enterprise. Inside of the Docker world, we have something called the Docker Trusted Registry, or DTR. DTR, it goes far and above the basic open source registry and provides substantial benefits that we'll walk through in a demo here shortly. I wanted to kind of talk through some of the verbiage here, that there's quite a bit, there's some terms that are maybe non-standard, but very quickly you can get the hang of the Docker build, run, and push as verbs that we utilize kind of in this space. The last thing to talk about from an introductory perspective with containers is how Docker images are built up. I mentioned that a Docker file is all the instructions that we need to create that image. But I'll go further and say that each image is composed of a variety of layers. We start with a base layer, so either Windows Server Core or Windows Nano Server. You'll be utilizing Server Core for any traditional or legacy application. So all of those .NET 4.5, 3, 2.0, you know, you name it. Any of these old legacy applications will install and run on Windows Server Core, whereas Nano Server is available for customers that are interested in pushing forward with things like .NET Core, the latest generation of the .NET programming language. These are typically for greenfield applications, microservice applications, really net new efforts that are coming into the organization. I mention that because Docker Enterprise Edition works for both. We're really targeting the entirety of your application portfolio, all the way back from your 10-year-old .NET apps to the apps that you're building here last week in .NET Core. We have a consistent platform for both. So in this example, we started with Server Core. Then we had an instruction in the Docker file to enable the IAS feature. Then we added .NET 3.5, we set some environment variables, and finally added in all of our ASP.NET application code. This is one example of what a Docker file may look like. And I wanted to call out that these are built up in layers for efficiency. So if I have an existing application that's utilizing the bottom 3 layers here, I don't have to resend those back and forth between environments. So we're very efficient in how we're able to transfer files back and forth, and how we're able to really decrease the amount of build time that it takes to build containers. So with that bit of intro, I wanted to switch over and start showing what some of this looks like. So hopefully, Sergio, correct me if I'm wrong, but if you should be seeing a Windows Server 2016 box that I have running up in Microsoft Azure today.
Yep, I can see it.
Great, thank you. So this is a pretty vanilla server, and what I want to start off with is showing the efficiency of containers. So I mentioned a moment ago we have something called Docker run. So what I'm going to do is I'm going to run an IIS web server inside of PowerShell. I'm going to loop through it 10 times. So if I hit go, we're going to fire this up, and we'll see that in mere seconds up here in Chrome, we're already connected in to an IIS web server that's running here on my machine. So in the kind of olden world of virtual machines, it typically would take much longer to create completely independent virtual machines running something like an IIS web server. But in mere seconds, we're able to spin up an entire 10 of them immediately, kind of showing the speed and how lightweight these containers are. This is real savings from a time perspective, and from an operations team perspective that's needing to get new versions of your code out the door and being able to deploy more quickly. So customers that are actively engaging in DevOps type practices and looking to ship faster than once a quarter, but they're looking to ship once an hour or multiple times an hour, containers and Docker Enterprise Edition are a great fit for that use case as well. So that is a very simplistic kind of example here, but we just wanted to show the speed with something simple like an IIS web server. But what if we have, our own application? So what I'm going to do is I'll open up everybody's favorite IDE, Visual Studio, and we'll do a little file new project here. We need some code if we want to containerize something. So I'm going to go over to a web application. We'll spin up an ASP.NET web app. We can be doing, let's go web forms, and very quickly I'll just scaffold out a project here so I can walk through the developer experience of what it looks like to develop a containerized application for Docker Enterprise Edition. You'll notice that I selected web forms simply because many legacy applications that we touch and that we work with are often in web forms, but we also support MVC, Web API, WCF, any of kind of the family of ASP.NET is certainly kind of our bread and butter. But if you've got older Windows services or console apps, those can also be containerized. There's quite a variety of applications in this space that are available to be containerized. So I quickly just launched this application. Good, and we have a simple ASP.NET web app running locally here in IIS Express. Okay, so we've got some code. Now, how do we go about containerizing this application? Well, first, I'm going to right-click on my web app. I'm going to say Add, and you'll notice here on the flyout we have something called Docker support baked directly into this. I'm running Microsoft Visual Studio 2017 Community Edition, the free stuff. But starting with 2017, we've got Docker support baked directly into the IDE. Back in the Visual Studio 2015 days, this was a first-party extension or add-on. However, this is baked directly into the IDE today. So if I select this, you can see that in my Solution Explorer over here, I have this Docker file that's situated here on the right. This Docker file is where Visual Studio has actually gone out and pre-scaffolded, pre-created a Docker file for me. It's looked at my project type. It's matched up that starting layer. I mentioned we usually start with something like Windows Server Core. We've gone a step further and started with a layer that already has ASP.NET installed for us. So we can start from kind of middle layers as well, which is very handy. We're passing in an argument when we build here. And this is really where we can go in and add all of the features that we need. So if we had a PowerShell script, we could run a PowerShell script here. We may add some environment variables for our app. Anything that we need to do to run our application would be happening right here. Now, Visual Studio is not going to be a silver bullet to completely containerize every nook and cranny of your app, but this is going to give you a starting point. Instead of starting with a blank screen, this gets you down the road. It gets you down that path, where then you can pick up where it's at and add anything that's specific to your application that you need for containerization. So now if I go and I hit debug, what Visual Studio is going to do is severalfold. First, traditionally Docker is very much a command line interface-based tool. That's where we kind of grew out of. For the Linux folks that like to live on a terminal window, that's very natural for them. They enjoy that. With Visual Studio, however, we abstract a lot of that from the developer and from the operators, as you'll see here momentarily. But what Visual Studio is doing is it's talking to PowerShell in the background to execute that Docker build statement that we mentioned a moment ago in the slides. So we're compiling our application that we have with the Docker file that Visual Studio created. And in just a moment, we'll see that we are going to open up a browser for our application. And once Visual Studio completes this operation, we'll have that application that'll be running in my environment. You'll notice here that instead of localhost, we have an IP address. So this IP address is not talking to my host machine on IIS Express. Instead, we're actually talking to a container. The application's running in that container on my machine here. And what's nice here is that if I wanted to come in to my Solution Explorer, maybe over to the contact page, I can open up this code, and I can do things that are very familiar to me as a .NET developer. So if I'm going through my page and I have a problem, boom, I hit a breakpoint. And if I hover over this page, you'll see that the Visual Studio debugger has actually connected in to this application running inside of a container and giving me that exact same debugging experience that I know and love with Visual Studio. Pretty exciting from a tooling perspective for the dev folks to be able to maintain that same experience, however, being able to develop, test, and deploy all via containers instead. So I'll continue through this piece, and we can see that my application loads as expected. Now this is the point as a developer. I've been working on editing this code project. I've been adding adding features, fixing bugs, all that good developer stuff. And now it comes time to, to check into source control. So typically I would check this into source control, into Team Explorer, something like Visual Studio Team Services, where I can then bake this application. I can go through my CI/CD pipeline, I can do a Docker build, and then I can push that into a registry. So I mentioned earlier that we have Docker Enterprise Edition comes with a registry. And to show you what that looks like, I'm going to open up Docker Trusted Registry. This is a rich GUI web-based application that allows you to manage Docker images across your organization. Furthermore, it comes with a variety of interesting security features. So we support both Linux and Windows containers. In this example, we've got an Nginx Linux container. And if I come into here, you can see that as I'm pushing, each row is a different image version, but as I'm pushing images, we can see we've got vulnerabilities here. So if I go into some details, we can see that DTR has gone through each of the layers in my Docker image and has given me very detailed information about different vulnerabilities that it detected. This is not just Docker saying that these are vulnerabilities. What we do is we actually test and compare your code against 7 CVE databases, these common vulnerabilities and exposure databases. They detected that there's an issue here in libxml, a particular library that's in that image. So what we can do from an operations perspective is notify your ops team when there's a vulnerability, and notify them as to what's wrong, and then how to remediate that problem by fixing the issues that are there. All right out of the box with Docker Trusted Registry. Furthermore, if you're trying to manage and juggle images across an entire organization with hundreds or thousands of developers and separate teams, it can be kind of hard to govern that. So also baked into Docker Trusted Registry is our ability to create organizations. These organizations are teams of users. And we flip over to the user section, you see that we've been able to plug into an existing Active Directory. We leverage existing security groups and then can assign that role-based access control that Sergio mentioned earlier in this presentation, so that particular users have the exact access that they need only to their exact repositories that they need to have access to. So we have a very strong security footprint here when it comes to organizing and governing images across an entire organization. So that is kind of a quick view of what we can do with Docker Trusted Registry. Great for teams, great for governing those teams across an organization, and ships with a variety of security features baked in to ensure that our operations teams are aware of vulnerabilities as they come up within our organization. So Docker Trusted Registry is the first of 2 main web applications that you get with a Docker Enterprise Edition subscription. This is the first, and the second is something called Universal Control Plane, or UCP for short. So if I open up UCP, you can see that this is a similar web application, and it gives us the ability to have a single pane of glass for our workloads. So we can see all of our container workloads and the actual cluster that we're running on. I'm running on a relatively small cluster in Azure today. We've got 3 Linux machines and 2 Windows machines. What's nice about this is that you notice I mentioned Linux and Windows. This single cluster can manage both our Linux workloads for our Java teams and our .NET workloads for our .NET and Windows teams. This is great in that we have one cluster to manage, one set of firewall rules, one set of AD, sync, one set of everything, instead of having to juggle 2 entirely separate infrastructures. Furthermore, we can carve these nodes up into particular dev, test, prod type environments. So if I wanted a development team to have complete access to a worker node here, we may partition that off and say, look, that's the dev team, have fun. Whatever you want to do there, you have full control. However, for my production nodes, I don't want my developers anywhere near that. We're only going to give permissions there for our operations team. So we have a lot of that exact same model around users, and Active Directory sync comes into play here with role-based access control, along with being able to grant particular permissions to particular teams of users. When it comes to deploying an application, we've got a couple ways here. We can step through a wizard type interface. So instead of having to hammer out on a PowerShell command line, we have this nice GUI. We certainly can use the command line if you prefer. Many devs do. Have at it. But for the ops teams that prefer the rich GUI interfaces that are coming from more of a system center operations manager background that like nice big GUIs, we have that as well. Or we can also deploy what we call a stack. So I'm going to deploy a simple web application called Howdy. Simply a little hello world piece here. And this is an XML file, excuse me, a YAML file with all the configuration that we need for my application. So typically I could have multiple tiers here. I may have a web app, an API tier, a database tier, a queue, everything I need for my app, all inside of one file that I can version, that I can check into source control, and manage just like any other asset in my repertoire. And we're going to give that to Universal Control Plane and say, Universal Control Plane, here's my configuration, schedule this container on one of the nodes that fits my requirements. And you'll see that we've created that successfully. So I can come in, I can inspect the services, and we see that I've got one instance of one that's up and running. So if I was to come over here and load a web application here in just a moment, the application will be up and running on that node, and we'll be able to load this here in the browser. What's nice about being able to manage this is that I can take an entire solution and bring that up all at once. This is a simple example with one tier, but I may have 4 or 5 different components for that app as far as APIs, databases, etc. I can manage the life cycle of that entire solution all as one, and then be able to update and patch that as one unit as well. So for some reason, our application is taking a moment here to start up. Sometimes some of the IS-based applications can take a second to warm up, so we'll let that get going here in a moment. But right alongside these applications, we have a variety of other apps that have been deployed. So I've got an agent that's talking to operations management suites. I've got Visual Studio Team Service agents, build agents that are able to build applications for me. I've got some monitoring capabilities here, all sorts of components that are working here. So very quickly, I'll switch over to an Azure portal here and show how I'm monitoring this solution. We give some rudimentary kind of basic monitoring capabilities directly inside of Universal Control Plane. What I'm also able to do is deploy an Operations Management Suite agent into that environment. Operations Management Suite, or OMS, as it's called for short, is a great monitoring solution from Microsoft. It runs up in Azure. It's a SaaS type offering. You install an agent and ship all of your information up into the service. Built into the service is a container monitoring solution that allows us to get very detailed information around the containers that are running, those that are stopped, any kind of errors that are being experienced, all sorts of information here on my workload. So I can dive into here, I can set up alerts. If something happens, I can be alerted. This is one of the great options of how we can leverage Microsoft's technologies to enhance and increase what we can do with Enterprise Edition out of the box. And again, since I'm running in that Azure Data Center, very easy to add these additional services here in place. So OMS is again, one very complementary tool that we're able to do with Docker Enterprise Edition. So I'll refresh this web app one more time, and it looks like we're loading here. And very quickly, you'll be able to see that we have our ASP.NET, that same application we mentioned earlier. I just added a container ID here. Why I wanted to mention that is that right now we have one instance of this application. However, if we have an application that is getting lots of traffic and we need to be able to scale this application up to manage it, we don't have to go spin up multiple new virtual machines and add them to load balancers and do configuration steps and all that other management that we've come to know and love. Instead, what I can do is I'll open up this service, and all in a wizard interface, I'll open up the scheduling tab. Right now we have one instance here. I'll scale this up to 5 instead. And when I scale this up to 5, what Universal Control Plane is doing in the background is it is instantly starting up 4 more of those applications, and it's deploying those across my node. So very quickly, we have 5 that are up and running. And then next time that we refresh the page, instead of saying F13, what Docker is going to do for us is add this behind a load balancer out of the box for us. And we're going to be able to round robin across that. You see we now have EAC. If we reload it again, we'd have an additional container on top of that. So these are all capabilities that are directly out of the box. When it comes to patching this, we could simply change the declaration for the container version that we want. UCP would manage that rollout for us. Very powerful when it comes to being able to update and manage application workloads that are running up in Azure, as well as those applications that may be running on-prem today. One of the great features of Enterprise Edition is that we work with Azure Stack. So all of these same capabilities you see here can work as part of a hybrid workload for users that are splitting deployment targets for both on-prem and for cloud-type products. So hope that's been a very quick look here at Universal Control Plane. Now we're able to manage the deployment of containers that are running on a cluster of machines up in Azure. We started back in Visual Studio with creating a container, showing that dev experience. Typically, we check that into Team Services, that then builds a container, pushes it to the Docker Trusted Registry, and then we can run that with the Universal Control Plane, all part of the Docker Enterprise Edition platform. So with that, we've got a couple more slides that I want to mention and call out. First is around the architecture. We touched on this a bit, but we deploy on top of a cluster of machines in Azure. So in the simplest architecture that we typically see, we would have something like a 10-node cluster here, where we have 3 virtual machines that are what we call managers. These are 100% focused on operating and managing the cluster. They're the switchboard operators, or the leaders of the entire operation, and that they're determining which containers need to go where. If a node goes down, or if there's any kind of irregular operations, the manager nodes are the ones that take the corrective steps and self-heal those application workloads. We deploy in a series of 3 for high availability. So if any one of these machines goes down, the other 2 will elect a new leader, and the cluster will continue on. There's not a single point of failure for those managers. Similarly, for Docker Trusted Registry, we deploy on 3 replicas for high availability, and if any one of those goes down, again, we're able to maintain the distribution of those Docker images. Not mentioned here is that typically for image storage inside of Azure, we'd utilize Azure Storage, the native blob storage capabilities of the platform that can store up to, I think, 500 terabytes per storage account. That's a lot of Docker images that we can store there. And so that's what backs Docker Trusted Registry. It's utilizing those first-party platform constructs that we have inside of Azure. Similarly, with worker nodes, when we say node, we're really meaning, an operating system. It could be bare metal if you were on-prem, but in Azure, this is going to be a virtual machine because we're in a virtualized environment. So node equals a virtual machine. These workers will typically be split between Windows workers and between Linux workers. And as far as how many you have is based on your operations. We have folks that are all in on Windows, and so they, have all of their worker nodes may be Windows. Others may have some other mixture based on the amount of Java or Node.js or other kind of Linux workloads they may be running. Coexist side by side, really up to you as to how many you need. Inside of Azure, we can also utilize first-party constructs like virtual machine scale sets and manage disks to make this more efficient and to allow us to be able to elastically scale the size of this cluster up and down as needed for our operations. In addition, from an add-ons perspective, this is where we can start talking about logging with OMS, Active Directory for our LDAP syncs, different kinds of monitoring solutions, certificate authorities, and image storage are all also additional capabilities that come with Docker EE on Azure. So I've been kind of talking about this a bit and kind of mentioned it throughout this demo. But one of the great things about Docker Enterprise Edition in Azure is that we are in the Azure data center. When you deploy this cluster in Azure, we instantly have access to all of these great services and more right out of the box. And furthermore, there's no egress, so we're not having to get latency hits, and it's also not hitting our credit card from a billing perspective with all that egress cost that's happening there. So inside of that data center, your applications can take advantage of these other services. So if I deployed an ASP.NET web application to my Docker cluster, it could easily talk to Azure SQL Database for relational data, Cosmos DB for any unstructured or NoSQL type data that's looking there. We talked about Visual Studio Team Services for doing continuous integration and continuous deployment for those containers. Azure Storage is utilized for Docker Trusted Registry or for any kind of persistent data that we need outside of those containers. OMS and Application Insights, great for monitoring those applications. And finally, Azure Stack. I mentioned it a moment ago, but we're seeing a significant interest here lately in utilizing Azure Stack and Public Azure as kind of the 2 legs of a joint cloud strategy of being able to running workloads on-prem and very effortlessly shift those to Public Azure or vice versa. Because an application is containerized, shifting from on-prem up to the cloud is very simple. We're not having to recode our applications or make substantial changes for running applications in something like, the Azure App Service that may be, whose sandbox may be a bit more restrictive than what we need for our app. But that portability works really nicely when we're going between Stack and Public Azure, all with Docker Enterprise Edition. So what I want to end on today is a little bit of talk about the orchestration options inside of Enterprise Edition. If you've been around the container space at all, you've likely heard the name Kubernetes. It's a very, very popular term that's out there today. And Kubernetes is an orchestrator. An orchestrator is the mechanism that is taking the requested containers and placing them on particular nodes. So if I need 5 instances of my web app, it picks out 5 nodes in the cluster and schedules a container on each of those 5. If one of those VM nodes crashes or goes down or is inaccessible, it's the orchestrator that will self-heal. It'll reschedule that container onto a healthy node to ensure that I stay with those 5 instances that are up and running. Kubernetes is an open source project. And similarly, we have the project called Docker Swarm, which is our first-party orchestrator. Both of these orchestrators are available in Docker Enterprise Edition. So what we've heard from our customers over the past year is Swarm is great for certain workloads, specifically Windows nodes and Windows containers, and that we've had GA support for Windows workloads for almost a year now. Whereas Kubernetes has some more sophisticated options, traditionally more in the Linux space, but they're rapidly adding support for Windows, which will be here later this year. So I call this out in that in Docker Enterprise Edition, operations teams can choose how they deploy a particular application or a particular solution. One team in your organization can be deploying on Swarm. Maybe they're all .NET. Maybe they want the most simple, integrated, fastest approach to container deployments. That's a great option for Swarm there. However, an additional team in your organization may want the bleeding edge capabilities and some of the more advanced features that Kubernetes offers, and may not be as locked into Windows containers. Say they're already doing ASP.NET Core, they're going to deploy on Linux anyway, and they want to go the Kubernetes route. Both these orchestrators exist side by side, and we give you that choice. So we are a enterprise-grade distribution of Kubernetes with all the same security, role-based access control, Active Directory integration. All these capabilities that we've been talking about work across both Swarm and Kubernetes. And finally, for developers that are working to develop applications to run on Kubernetes, I want to make sure you check out Docker for Windows and Docker for Mac, our developer tools that deploy to developer desktops. On the edge channel of these products, you can have support for Kubernetes today. Let's see. Once you download and run the latest versions to that edge version, Kubernetes is available. You'll be able to run and deploy those apps via Kubernetes, no longer having to use projects like Minikube and other kind of traditional ways of doing this. So with that, that's been a run-through of all some of the technical pieces that fit together from a Docker perspective. So we talked about creating a container in Visual Studio, deploying through DTR and UCP, and some of the orchestration options that are available to users that are deploying today inside of Azure. So with that, Sergio, I'll turn it back over to you here, and I will pass you the ball right now.
Great. Thanks, Stephen.
Thank you.
Let's see. Hopefully you guys can hear me. Let me just quickly go through. I should have just, there it is. So for those of you that are looking to begin the journey or further down the journey and would love to engage with both Docker and potentially Microsoft, we have a variety of options available to you that we can help you really think through end-to-end how to start your journey or how to integrate into where you are today to make sure you're really getting true value from Docker, and if you're choosing to run on Microsoft Azure, that will really help you take advantage of those services as well. And so you can see here we do have an extensive offering, and ultimately it just comes down to where you are, and then we'll have the right level of discussion with you. And so we're certainly very interested, so just keep that in mind that we're here to help guide you, as I said, every step of the way, whether you're just out or whether you're already down the path of evaluating and or deploying containers at scale.
Hey Sergio, sorry to interrupt. I don't think we can see your screen. If you're sharing.
Let's see. Thanks for that. I thought I was. Okay. Let's see. How do I? You know what? I don't see where I am. I don't have the presenter rights anymore. I don't know what happened.
Yeah, you should.
So let's see. I'm connected, and then when I click, right click, it usually says, let's see. Yeah, how about if we just make Stephen the presenter, and then we'll just get through the last couple of slides.
Yeah,
I don't know
that'll
why.
work.
I'm not sure why we're having that issue here. Anyway, no worries. Yeah, so let's just go through that, and I won't spend any more time on this only because I kind of walked through it, but essentially this is kind of the journey that is available from Docker, and certainly will engage with Microsoft to help you along your path as you look to containerize your applications and evolve your modernization to Docker and to Azure. So let's go on to the next slide now. So we've only got 3 minutes left. If there are any questions, feel free to add them into the chat window, and then we can certainly address them. It says, so let's see, are we sharing slides? Yeah, we are going to make a PDF version of the slides available to you. Yes. OMS agent, is there a Docker image available for it? Stephen, do you want to take that?
Sure, absolutely. So the OMS team does distribute a Docker image for OMS for the Linux side. I'm not sure if there's one available today for Windows yet. Typically, you'd install the agent, the Microsoft Management Agent, to the host machine, but there is one for Linux available today under the Docker Hub for Microsoft/OMS.
Okay, and another question was, should we use availability set or scale set when deploying Docker EE?
Great question. So what I like to do is a bit of both. So since my managers, I know I'm really going to stick to 3, and I'm usually not going to scale those up and down elastically, I'll put all 3 of my managers in an availability set of single VMs. Same for my Docker Trusted Registry nodes. So I'll put 3 of them in an availability set because they're relatively static. It's my worker nodes that I really like to elastically scale up and down based on the amount of resources that are available or the time of day, and that's a great use for virtual machine skill sets to be able to get that kind of capability. So it's your choice, and you can run both based on your needs. What I see most often is mixing those together to get a very flexible environment.
Okay, and then I think you touched on this a little bit. Is there any documentation we can point to regarding the OMS agent?
Good question. So I think my screen is still coming through.
Yeah, it is.
So what I can do is, if you check on the Docker Hub, this is a public registry, similar to Docker Trusted Registry, but all public. And what we have here is under the Microsoft org, they maintain this OMS agent here. They've got a full description about the supported operating systems. They actually also have an entire set of documentation on Azure.com on one of these links here that can walk you through how to do this. They update this pretty regularly. You'll see 12 hours ago they pushed an update to this image that's there, and you get the command that's running here. So it's a pretty straightforward process for integrating operations management suite with something like Docker Enterprise.
Cool. Okay. So we've got 1 minute left. So Stephen, you want to just turn to the final slide? First of all, we want to thank all the attendees for participating. We greatly appreciate it. A couple of resources available to you right now. Obviously, come to docker.com Microsoft to learn more. We do have an ebook, and we'll include this in the PDF. This is a live link, and it's really more a business guide, and it'll help give you an overview of how we're partnering with Microsoft to help modernize your applications with Docker EE. There's DockerCon that's coming up in June, and there's a link there to register. And then our next webinar, part 2, is running a secure application environment with Docker Enterprise Edition and Azure. And then, of course, you can always feel free to contact us directly. So with that said, it's 11 a.m., and so let's go ahead and call it a thank you so much, everyone, for participating. We will reach out to you to remind you about the upcoming event on May 16th, and we will include links to the ebook as well as to DockerCon, and then we'll take it from there. Okay, thank you again, all. Do take care, and again, thanks again for participating.